And video number 3, let's talk about some renewable energy resources and see how this has evolved over time. Looking at how much electricity are we now producing from from renewable energy resources versus before. And what we can see from that graph is this amount of energy from renewable resources has been increasing. So this is a good thing. The downside of this graph is it doesn't compare it from fossil fuels, which is, of course, still a minority of production versus the amount of energy produced from fossil fuel. However, we can see that there is a tendency for a pretty good increase globally. It's a global graph, meaning the worldwide. There is an increase in production or generation of electricity from renewable energy. Remember that renewable energy is mainly used to produce electricity. And from that, this lists the different sources, which will be the ocean. So ocean, mostly tide and waves. The geothermal power, so the energy coming from the ground, the biopower, mostly wood and crops, that is being the biomass power, then solar photovoltaic cells right here. Then we have the wind power, windmills, like we can see right here, and the hydropower, mostly dams. So what we can see is, in general, we observe some that didn't increase too much. I mean, a bit of dams, a little bit on the ocean and the biopower, but that has been kind of very inconsistent and not a huge increase. The one that has increased considerably over the last 10 years or almost 15 years now has been the wind power that we can see multiplied easily by 4 or 5, and solar panels. Through kind of huge increase in technology about 15 years ago, has gone from almost nothing to a big portion, about representing what? A sixth, more or less, of all the production of energy, electricity made from renewable energy. This energy production represents about 18% right now of the world electricity. In the US, we're mostly around this about 20%. You see on this graph right here, and after it depends on the sources. 18% was in fact a couple of years ago, about 2018, and it's a difficult one to estimate. On this other resource that I took from the International Energy Convention, it is estimated that about 25% of the energy nowadays is made from renewable resources in the world. The majority of these renewable resources, in fact, comes from dams and hydropower, which is the main source of renewable energy resource in the world. In the US, we do have some consequent amount of renewable energy resource coming from dams, but the big increase that we have noticed over the recent years has come from more solar panels and more windmills, wind power, which allows us to reach this about 23% estimated by 2022. The good side of it is, thanks to that, we can reduce our consumption of fossil fuel on the counterpart. So this is what's supposed to happen in the future by 2050, having more than 50% of our electricity coming from renewable. In the California, for now, we're about 30% of our energy coming from renewable, taking into account also the hydropower, the solar, and wind, which is right here. So that's counting about for 30%. It's normally targeted to go up to 50% by 2025 and 60% by 2030. So there is a huge motivation for California to be one of the examples in the US, but also in the world to be generating electricity majorly from renewable energy resources. That was, in fact, I forgot to mention, that was from 2016, and you can see 2018. Why are we also able to move to renewable energy? Because thanks to technology, thanks to the fact that those products are becoming more popular, more available, we have been able to drop the price, in particular for solar panels. 15 years ago, solar panel energy was crazily expensive. In fact, it was the most expensive way to make electricity. It was not worth it. But you can see that in about 10 years, we've been able to drop considerably, moving from the top highest, most expensive energy resource to the cheapest one at this point. Cheaper, in fact, than the onshore wind. So all those turbines we see close to cost in itself. So in the same time, we have seen other one dropping price, such as natural gas, thanks to also advancement in technology. But that has been a huge impact on the fact that we can turn into solar panels because it's cheaper to produce electricity from solar panels than maybe producing from any fossil fuel energy or nuclear. In fact, you can see that nuclear energy has increased over time. The reason for that is mainly because nuclear energy power plant require maintenance, and over time it requires more and more maintenance, and so the energy has tend to have cost more and more because we have not built new factory, no new power plants. We have stayed with the old ones, so the energy tend to have increased over time. Unfortunately, not everything is as great because most of the investment nowadays are not made in the developed countries, but in fact, they are made in the developing countries. With the crisis of 2008, 2010, before that crisis, the developed countries were making huge investment into renewable energy. But because of the market going down, those countries decided to cut their share and the investment inside of renewable energy. And since then, over the last 10 years, we've seen a change and a shift with developing countries spending more investment, more money into renewable energy than developed countries. So this is not the way it should have been going, but it is kind of what's happening, which is good for those developing countries because they will be probably emitting less than what we did when we did our economic transition. Another thing too that goes into the critics a lot is the fact that by going to renewable energy, we are losing jobs because those working in the petroleum, coal, and natural gas industry will lose their jobs. Well, there are formations that allows to make a transition, but has been shown that overall, the employment switch of energy resource from non-renewable to renewable will create more jobs than it will destroy. We can see the amount of jobs being happening in coal and oil, and all the amount of job that can be created with non-renewable energy resources. This overpass the amount of jobs right now used. So it has a huge potential of employment at this point, with a major site in the world being in Asia, India, China, and Indonesia, where most of the employment will be done, a lot also in Europe and a lot after in North and South America. But so this is a kind of a fake idea that going towards renewable energy will lose jobs. It's not true. Then let's go quickly about each of those different type of energy, about renewable energy. Let's see first solar energy and kind of a natural passive way to use solar energy. First, let's consider a house where we have windows. Well, the idea is you let the sunlight coming into your house, and this will warm up naturally your house. This is what we call the passive solar heating. Another way is that you will expose some of your roof to the sun, and that can be used to warm up, for example, a hot water storage. You may have some pipes going through your roof, and that will warm up the water that will allow to distribute that heat into the floor. And the same can happen during summertime. You have the cooling system that will be linked to the pipe in the ground that will allow to cool down your house. So you can play on the sun and the ground to warm up or cool down your house itself. Then you can also intensify that by using dish concentrator or what we call parabolic throw or heliostat central receiver. The idea is mostly you concentrate your sunlight to one point that can be either a photovoltaic cell sometime, or most of the time it's a water tank that will be used to warm up this water tank, generate some steam. The steam will turn a turbine that will link to a generator, and that's producing electricity. So those type of techniques are used often, those passive techniques are used to produce electricity. Nowadays, we see more and more of what we call the photovoltaic type of electricity generation, which use, in fact, those solar panels. Those solar panels have some component in it that will transform the photons directly into electrons, into electricity. And so it's a more active way of using solar energy and to produce electricity from a photovoltaic cell. So this is for solar energy, which is the one increasing the most in terms of production at this point and being the less expensive. We move towards wind power, wind turbines. We see them popping up a little bit everywhere nowadays. These wind turbines are working very simply. You're turning a turbine thanks to the wind. This is linked to a generator that produces directly electricity and that will be distributed to people. They have some people complaining about it, they don't look nice, and so people are trying to invent other type of wind turbines, also because it has a big impact on birds population and bats population. Imagine a bird going through, there is a big chance of that bird to not survive. We do, of course, have the old European style that are more like now monuments. They were used before not to produce energy, but mostly to ground any cereals. That was the main function of those windmills at that time. But we have a lot of wind turbines that are found usually close to the coast, the most exposed region of the world by wind, and also offshore because winds tend to be, in fact, more constant and stronger offshore. So this is kind of a field of wind turbine that is observed in Denmark. Denmark has the biggest offshore wind turbine surface of any other countries. Then we do have some engineers trying to find new shapes to protect the biodiversity, such as those ones, this type of wind turbine, or this one that I haven't followed. This one seemed promising to avoid birds and bats to be killed, and also was working with very little amount of wind, oppositely to this wind turbine that need at least a minimum of wind and don't work after a specific maximum speed, wind speed. So those ones were more adaptable. So there is some work being done and trying to make those more efficient and more more adapted, in fact, to the ecosystem. Then places such as California tend to enjoy some geothermal power. This is a heat that can come from the crust. Mostly, some places tend to be warmer than others, mostly when we are close to tectonic plates with some volcanic activities, which is a case of California has still some volcanic activities in the north part of the state. And so this bring usually some the ground to be hot and potentially some water to be hot. We do have some hot spring over there. And so we use this hot water, we build a well, this will release some steam, we link it to a turbine, and we're producing electricity, and we're sending back this water or the fluid toward the soil after. So this is something that is used in the north of California, but also the places such as Iceland has a huge potential for geothermal power. And other places in the world. But overall, this is very limited. And so if we look at the limitation geographically, we can see that happens for solar, for wind, and for geothermal. For solar energy, mostly you're limited between the 35 degrees north and south parallel. This is where you have the maximum amount of solar exposure. Outside of those zones, you have less exposure from the sunlight, and so your solar panels are not as efficient, but still you could do it. But this is showing you the most efficient region of the world using solar panels. Winds, you see that winds tend to be the highest in the sea because there is less friction. Water is not providing too much friction. As soon as wind reaches the land, there is a lot of friction, and so there is a huge decrease of wind, in particular with mountains, for example, we can see. And so that kind of limit the potential location of the windmills. That's also why we do it quite a lot offshore, because it tends to be more efficient. Finally, the geothermal places are limited mostly to tectonic plates. That's what California is a good place, but not the east part of the US, for example. We can find it on all these tectonic plates. Iceland is one of the best country, and we do have on all what we call the Ring of the Pacific, the Ring of Fire, are places where ideally geothermal power could be used. A quick other ones to talk about. We didn't mention anything about hydropower, the fact that we're using the flowing water to produce electricity. Most of the time we use dams. So we cut down, we split a river or a lake linked to a river. We place a big dam into it. And so the lake becomes a reservoir, or the top part of the river becomes a reservoir. And we allow only a little portion of the water to go through pipes. And this will move a turbine as it's flowing from the reservoir to the downstream. This turbine will spin, linked to a generator, it will produce electricity. This is the most efficient way of producing electricity, 90% efficiency. It is the best way to produce electricity from the resource in itself. But unfortunately, it has a lot of damage on the environment. It tends to be destroying potentially portion of the rivers, removing habitats, also cause some kind of pollution that are not ideal. So dams, they tend to be the most efficient one, but they have a pretty high cost on the environment. We can also use waves and tides to produce electricity. Through the motion of wave, we're able to create a free motion that will make turning a turbine and generate electricity. Or, for example, with the tides, we have the system of buoys in the ocean that will also make the flow of water going through a turbine linked to a generator producing electricity. The downside is, imagine you're a fish going through that turbine, well, you're ending up being like a sushi. So there is also impacts on the environment and on especially on the biodiversity. With this map, I forgot, in fact, to mention to you the distribution of dams and the potential of dams. So in blue, you see all of the installed capacity, and in green, the estimated generation, the maximum that we could be doing in terms of electricity generation from dams. So in general, we are far away from what we have, from what we could be doing. And in particular, the biggest region for dams, dam-generated electricity is in South Asia, Indonesia. That is the biggest portion of the world because of the number of rivers that is there, would allow them to have a huge portion of electricity coming from dams. But again, that has a very high impact on the environment, and it's kind of limited at this point. Quickly, I'll go over the downside of each of those renewable energy resources with this table. I'm not going over each point, you can review them. Solar energy has become less expensive. It's still kind of expensive because you need a lot of solar panels to produce a specific amount of energy. So there is still a little issue regarding the expense, but it's getting better and better. It's also intermittent because it needs to be powered by the sun. Of course, doesn't work during nighttime. The components tend to be, how to say, very hard to extract. And so there is a need of an exotic material in some way that is having a high cost on the extraction. And also we have issues on recycling also. It's asking for a lot of space. Wind, well, you need to have the right condition of wind. So it's not always that you can use the wind turbine to produce electricity. It has a big issues on the biodiversity. Some people don't like those wind turbines. So it can be an issue to implement wind turbines in some places. Geothermal, as we saw, was defined by specific location, has issues of pollution, of soil pollution that can be a prime. It tends to be expensive, and it's not that reliable comparison to other resources. Then finally, hydropower electricity tend to have huge impact on the environment. We saw with dams, you're removing habitats, moving species, destroying part of the ecosystem. The same with the tidal and waves power electricity, where you can impact on the biodiversity. It can be expensive. The problem right now we see it with California is when you have a drought, what do you do? Those are all issues. And to end up this video and this part of the lecture, I just want to remind you that renewable energy is a good thing. However, renewable energy doesn't mean that it's a clean energy. I mean, it's still having some impact on the surrounding, on the species, on the environment. And so it is not a green energy, sorry. The green energy refers to the fact that it doesn't impact on the environment, it doesn't impact on the biodiversity. it still has some issues regarding that. And it's not a clean energy because it tends to still potentially emit sometimes some CO2. It can still participate into the global warming, such as, for example, hydroelectricity has been shown to release some methane that participate into global warming. So renewable energy is a good thing, but still produce some side effect on the environment, and we should not forget about it. With that, we are done with this video number 3. I thank you very much to have held up to that point, and I invite you to join me for the last video on which we're going to talk about alternative energies, resources, and how also we can be a bit more efficient in our use of energy. See you in a